Hello everyone. In this video lecture session, let's have a look about quantum theory. First of all, quantum theory. The term quantum in the sense it is going to deal about radiation, black body, everything and all. So let's have a discussion shortly about what is quantum, what are all the introduction about the quantum, and especially major important aspect about energy quantization. In the energy aspects, how the quantum theory is applied. First of all, before going for the quantum theory in detail, let's have a consideration about the origins of quantum mechanics. First thing, origins. Once upon a time, motion of atoms from the chemistry concepts, if you are detailing going, subatomic particles could be expressed during classical mechanics, laws of motion introduced by Isaac Newton, everything, these are all basic scientific principles. How we are going to relate this origins with the quantum mechanics? As I mentioned in the first line of the slide, we are going to deal with the blackbody radiation. So before going for that, we have to interlinkage the pattern which is happening with the help of the motion of atoms and subatomic particles, because it could be expressed in terms of classical mechanics with the help of the Newton's law. So that's what the origin, the laws of motion introduced by Isaac Newton, everybody knowing. What is the purpose of Newton's law over here? Because it is the basic thing. From there only all the interconnected patterns starting from motion of atoms, subatomic particles could be expressed the overall view in the classical mechanism. So look at the third point. Experimental evidence show that classical mechanics failed. So initially what scientists did, they are doing many experimental over in this quantum concepts, and it was applied to the particle as small as electrons. So initially failure happens. Already the evidences was framed that classical mechanics was failed. Then they are applying into the particles as small as electrons, because initially they are trying with the motion of atoms, big atomic particles, everything in the classical mechanics concepts, but that experimental evidence failed. Then they applied to the particles as small as electrons. So small tiny electrons they referred, and they are applying this quantum mechanics concepts. Then they succeeded. So in the year 1920s to discover appropriate concept for this overall equation today we are applying in our day-to-day life concept. So the origin of quantum mechanics starts after the failure happening in classical mechanics. Then Newton and some more scientists referred the particles which is as small as electrons. Then the appropriate concepts happens, the equation derived, finally the concept of this new mechanics described as quantum mechanics. What is this energy quantization? Quantum mechanics, fine, these are all the things after atomics, atomic particles, everything and all. Then finally we are going for the final Isaac Newton's laws, and then finally we are applying for the small tiny electrons. But the overall energy quantization, what is this quantization? The quantization of energy refers to the absorption or emission of energy. So first of all, quantization of energy. Absorption is happening, at the same time emission is also happening in discrete packets or quanta. So the first key parameter is in which level the energy is delivering, whether it is absorbing or emitting in discrete packets or quanta. So the quantum, the word quantum plays a vital role, because every concept is interlinkage. Look at the second line. As the intensity of electromagnetic energy increases or decreases. So the overall intensity of electromagnetic energy increasing as well as decreasing, it steps ups or down, but level to another level it keeps on varying. So what is our major point of view? Quantization of energy refers to the absorption. At the same time, emission of energy is also happening, but in discrete packets. At the same time, in quantum, both are same, discrete or quanta, whatever it may be. But the energy liberation with the help of the intensity of electromagnetic energy increases or decreases. It steps up or down from one quantity level to the another quantity rather than smooth or continuous curve. So this is what the energy quantization major concept behind this. So after defining this major energy quantization concept, we are establishing the energy quantization concept called a replacement of classical mechanics. As I already mentioned in the previous slide, that is failed because of experimental investigation. They already tried for big atomic particles, they failed. Then the scientists decided to deal with small electrons. So establishment of this energy quantization, they are replacing instead of classical mechanics. They are making a new form of this energy quantization that consists of three major studies. One is blackbody radiation, another one is heat capacity, and the third one is atomic and molecular spectra. So this is the way how the energy quantization came here all over the world, how we people are dealing our day-to-day life scientific applications. Potential energy, look at the example. Potential energy of person walking up steps increases in stepwise in a quantized manner. The potential energy of person walking up a ramp increases in uniform in a continuous manner. Look at the steps, stairs, whether he is climbing one by one or whether he is going slantingly. So it depends how the energy quantization become evident under three major categories. So for this major categories, blackbody radiation, heat capacities, atomic and molecular spectra comes under this energy quantization after the failure of the classical mechanics. Then they are treating with the electron particles because it is small. Then finally it was decided to deal with these three main studies that is coming in the form of blackbody radiation, heat capacities, and atomic and molecular spectra. Here comes the first point of view, blackbody radiation. The classical approach to the description of blackbody radiation results in the ultraviolet catastrophe. Look at the graphical point. In the x-axis wavelength, y-axis energy distribution. So first, blackbody radiation. Commonly speaking, a classical approach from the early days to our modern days, it is determining the ultraviolet radiation starting from our temperature, starting from our wavelength, how it is keeps on increasing. So look at the second point, the prediction of classical physics. So everything I am referring from the previous thing, the olden days time, ideal blackbody at thermal equilibrium will emit radiation in all frequency ranges. So look at the figure, parallelly look at the figure and the points also. In the figure it was mentioned clearly that wavelengths it keeps on decreasing, increasing, ups and downs. Energy distribution it keeps on in the y-axis level. So maximum at one point, the peak level it is achieving. At the same time, depending upon the increasing of temperature also it is happening. So the prediction of classical physics dealing the ideal blackbody at thermal equilibrium. At the same time, it is emitting radiation in all frequency ranges. And also the last point indicates it emitting more energy at the same frequency when it increases. So two things here we are considering. One is we are considering ideal blackbody at thermal equilibrium emitting the radiation in all frequency ranges. At the same time emitting more energy also when the frequency is getting increased. Let me look on the third point. How about the sum of emissions in all the frequencies? The sum of emissions in all the frequency ranges suggested that blackbody would release an infinite amount of energy, contradicting the principles of conservation of energy. So what they are mentioning, frequency ranges may vary, plus, minus, increasing, decreasing, maximum, minimum, but the releasing is happening infinite amount of energy. At the same time, principles of conservation of energy we have to follow, so that this blackbody radiation concepts will be succeeding at the most specific as well as technical as well as the increasing pattern in our day-to-day life applications. So, the sum of emissions in all frequency ranges suggested that a black body would release an infinite amount of energy, contradicting the principles of conservation of energy. This draws attention to the need of a new model for the behavior of black bodies. What is specifically black bodies? What is happening inside this black body? Look at the figure as well as the equations are mentioned. First of all, let's have a look about this black body radiation. Good approximation to a black body is a pinhole in an empty container, maintained at constant temperature. In the previous slide, as I already mentioned, maximum temperature, it keeps on increasing. But our major point of view is good approximation to the black body is a pinhole in an empty container. That indicates empty container consisting of the overall parameter maintaining at the constant temperature. So temperature aspect we have to consider, at the same time approximation we have to maintain, then only our overall black body radiation result analysis will happen. Look at the next point. Any radiation leaking out of the hole has been absorbed and re-emitted inside. So whenever it is getting reflected back around or inside the container, it has to come with a thermal equilibrium. So what is happening here? Radiation leaking out of the hole, absorption is happening, emission is happening, but black body radiation coming in the formation of the thermal equilibrium inside the walls. That's what the arrow mark, look at that yellow color arrow mark which was mentioned inside the black body radiation. Conceptual black body which I was mentioned along with the equation, what is they are mentioning is energy density. Look at the last line, 19th century approach only energy density. Before that they are mentioning only the observation absorption, emission, everything. Then only they are identifying the energy density. From that energy density, this equation are derived. Look at that 8 pi kt lambda power 4, everything Rayleigh-Jean's law for the density of the states. Because while talking about energy density, we have to undergo this conceptual black body. So while considering this energy density in this black body radiation, the overall observation is happening inside the container by considering the constant temperature. The same continuation black body radiation, Rayleigh-Jean's law, is quite successful at long wavelengths as well as low frequency, but fails badly at short wavelengths. This is very important point in analytical view, because initially whenever they are determining the energy density, longer wavelength at the same time lower frequency, it is successful. But shorter wavelength which is having higher frequency, it is failing, because the prediction, we cannot exactly predict, the approximation point is missing. So look at the third point, equation predicts that oscillator of very short wavelength. Then it was decided by comparing with ultraviolet radiation, X-rays, gamma rays, everything they have decided at the room temperature. Finally it was mentioned as ultraviolet catastrophe. So this absurd result implies large amount of energy. The fourth point which is indicating we have to imply the large amount of energy because radiation is happening in the higher frequency region. So the radiation is clearly indicating higher frequency region of the electromagnetic spectrum. So according to the classical studies, even cool objects should radiate inside the visible and ultraviolet regions. But at the same time, objects should glow in the dark. There should be in fact no darkness. So this is what black body radiation mechanisms. So longer wavelength, shorter wavelength, high frequency, low frequency under this ultraviolet catastrophe. This is what we have to consider in the analytical point of view. Here comes the continuation in the analytical point of view. To avoid this catastrophe, Max Planck have described the quantization of energy. What is that quantization of energy? Electromagnetic field could take up energy only in discrete amounts. That is quantization of energy. This fits the experimental curve at all wavelengths. For long wavelengths, it is happening at the same time. Shorter wavelength, higher frequency, longer wavelength, lower frequency, it also depends. So depending upon this, quantization of energy is happening only in discrete amounts. Here comes the heat capacity. While talking with the blackbody radiation, we have to consider the heat capacity aspects also. The French scientist discovered that CV point of view in a number of monoatomic solid. At the same time, he proposed molar heat capacity of all monoatomic solids are the same. At the same time, it is close to 25 joule kilo per mole per. because here they are setting one ranges Dulong or a peninsula. It's easy to justify in terms of classical physics. At the same time, significant deviations also happen because it was observed. It's not generally mentioned. It was evidently proven, scientifically recorded techniques, advances in refrigeration techniques made it possible to measure heat at low temperature. So heat capacity is a major phenomenon while considering dealing with the blackbody radiation concept. Heat capacities, then only they are fixing the overall concept along with the low temperature aspects. Here comes the continuation. It was found that molar heat capacities of all monoatomic solids are lower than 3 are at lower temperature. Einstein formula is also derived. Planck's hypothesis also derived. Single frequency is also derived. So while considering this heat capacities, we have to observe all the frequency aspects, all the hypothesis, and finally Einstein's formula is derived. So atomic and molecular spectra. In dealing with this blackbody radiation, the most compelling and direct evidence for the quantization of energy comes from the spectroscopy. So the spectroscopy is the detection and analysis of electromagnetic radiation absorbed, emitted or scattered by the substances. So this is our major basic formation of this atomic and molecular spectra, because in the modern agenda they are framing and detecting the analysis of electromagnetic radiation, whether it is absorbing, whether it is emitting, or it is scattering. So overall the substance is getting absorbed. At the same time, look at the first point, most compelling and direct evidence for the quantization of energy comes. So that is also takes place in the spectroscopy. Obvious feature of both the radiation is emitted or absorbed at the same time. Discrete frequencies also to be noted. Look at the fourth one, energy of an atom decreases by del E. So energy getting decreases, energy is carrying, the emission is happening, but sharply defined peak appears in the spectrum. So we say that molecule undergoes spectroscopic transition, a change of state when the Bohr frequency condition del E equal to h mu. So this is what the atomic and molecular spectra frequency level in determining the blackbody radiation. Here comes the reference materials for downloadings, as well as our understanding concepts, environmental science and energy books, textbooks, as well as reference materials also available, animation concept links also available. Anyone can refer accordingly. You will be getting more and more clarity. Thank you everyone for your patience listening. Thank you all.